Hello and welcome to another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 6, Lesson Number 1, Simplifying Expressions Involving Exponents. Before we begin this very important topic, let me just remind you that you can find the worksheet and a homework assignment that go with this video by clicking on the video's description or by visiting our website at www.emathinstruction.com. As well, don't forget about the QR codes at the top of every worksheet. If you scan those with your smartphone or a tablet, it will bring you right to the video associated with the worksheet. All right, let's begin. Now, previously in this course, we had talked about exponents and how they behaved and how to think about them. So the first exercise is really just a review of a lot of different basic skills associated with exponents. What I'd like you to do is actually treat this as a warm-up problem. Pause the video. Take whatever time you need, maybe up to 10 minutes, and work through each one of these 6 problems, and then we'll go through each one of them in turn. Okay, pause the video now and see what you can remember about exponents. All right, let's work through them. Letter A says represent 6 to the third as an extended product, don't evaluate the product. All right, no problem, right? 6 times 6 times 6. Thank you for telling me to not evaluate the product. So just at its most basic, what does 6 to the third mean? That's it. All right. Letter B, we have a little bit of function notation going on. If f of x equals 2 times x cubed plus 7, what's f of negative 1? Well, remember how we interpret function notation. Wherever there's an x, we put in a negative 1. Keep in mind your order of operations. We have to do negative 1 cubed first, right? That's negative 1 times negative 1 times negative 1, right? That all ends up being a grand total of negative 1. So that will be 2 times negative 1 plus 7. Now the multiplication, that gives me negative 2 plus 7, and that gives me positive 5. All right, so just a little bit of function notation. All right, letter C, if x to the third times x to the fifth is written in the form of x to the n, what is the value of n? Write extended products if you don't remember the exponent rule. Well, let me just remind for you the exponent rule. We had an exponent rule that said that x to the a times x to the b was x to the a plus b. So that means x to the third times x to the fifth is x to the eighth. So n is 8. Remember to always answer whatever question is being asked. Don't just leave it as x to the 8th. They wanted the value of the exponent, and that's 8. Letter D is even trickier. Something like this could easily show up, let's say, on an SAT problem. If the expression 5x to the third squared is written in the form a times x to the b, what's the value of a plus b? Well, a lot of people get confused when it looks like this, but don't forget, at its essence, what that is 5x to the third times 5x to the third, right? That's what it means to square something. Now I can use the associative property of multiplication to rearrange this a little bit and rewrite it like this, right? 5 times 5 times x to the third times x to the third, but that will be 25 times x to the sixth using that property from over here. Now, what that means is that a is equal to 25 and b is equal to 6, but a plus b, which is what they ask for, is equal to 31. All right, letter E, little bit of what's known as scientific notation. If the length of a rectangle is 3 times 10 to the 5th meters, and its width is 2 times 10 to the 4th meters, what is its area written in scientific notation? Well, as we should know, the area of any rectangle is its length times its width. So in this case, that will be 3 times 10 to the 5th times 2 times 10 to the 4th. But again, we can use that associative property, of multiplication to actually multiply the 3 and the 2. And then the 10 to the 5th times 10 to the 4th. 3 times 2 is obviously 6. I'm going to use the times symbol there. Here we can use that exponent property again. It doesn't matter if the base is a number like 10 or a variable like x, but 5 plus 4 is 9, so we'll have 6 times 10 to the 9th, and that'll be square meters. Don't forget your units. All right, finally, letter F. Rewrite the product 3x squared squared times 2x to the fifth cubed as an equivalent expression in simplest exponential form. Look, if you don't know what else to do, always start with the basics. So 3x squared squared is this. 2x to the fifth cubed is this, right? Now we can use the associative property of multiplication to group all the numbers together, i.e. 3, 3, 2, 2, 2, and all the variables, x squared, x to the fifth, x to the fifth, x to the fifth. All of this, 3 times 3 is 9, times 2 is 18, times 2, actually, maybe I'll just do 9 times 8. That'll be easier, right? 3 times 3 is 9, 2 times 2 times 2 is 8. So that'll be 72x, and now we can add 2, 2, 5, 5, 5. Those 5s all come out to 15, plus 4 is 19. 72x to the 19th. So how'd you do? Right? How'd you do on these? Hopefully well. All of them really required just two things: a basic knowledge of what positive exponents represent, and that basic exponent law that says add two exponents when you multiply quantities that have the same base. Okay. But we're going to go on now and start to simplify exponential expressions that involve division. So I'm going to clear out this screen, pause the video now, and write down anything you need to. Okay, here it goes. All right, let's move on. So today what we're going to be doing is we're going to be playing around with expressions that look like this. We're going to try to simplify things that look like 2x to the sixth divided by 4x squared. And letter A says write this expression as the product of two fractions, one of which is equal to 1. Well, before we even do this, I want to make sure that we have a little primer, okay? And that little primer is how we multiply fractions. All right, so if I gave you this problem, 2/3 times 7/5, right? Would you know how to do it? And hopefully the answer is yes, because you've learned this back in middle school, right? To multiply two fractions is almost the easiest thing on earth because we simply multiply the tops and we multiply the bottoms, okay? Multiply the numerators, multiply the denominators using the correct terminology, tops and bottoms. But the idea here is that we can also unmultiply, right? If we can go this way, we can go that way, because equality is a two-way road. It's like, you can go this way, you can go that way. So let's take a look at this top fraction, okay? We've got 2x to the sixth divided by 4x squared. Now, think about this for a minute, right? That's 2 times x to the sixth, but on the bottom, it's 2 times 2x squared, all right? And in fact, we can write one of these fractions equal to 1 as long as the thing in the top, the thing in the numerator, is the same as the thing in the denominator. Well, what's common to both things in the numerator is that factor of 2. So this is actually a GCF problem. And what's common to both the numerator and the denominator in terms of x is x squared. So think about this for a second. Let me write it down, and then let's talk about it. This and this product are equivalent. All right, how do I know that they're equivalent? Because if I multiply them back out, I get this again, right? So this entire fraction is equal to 1. Anything divided by itself, except for 0, is equal to 1. So it's beautiful because now I can simplify the expression by saying that that first fraction is equal to 1, the second fraction is equal to x to the fourth divided by 2, and so overall the fraction is equal to x to the fourth divided by 2. Now that probably seems a little bit complicated, and I agree, it does seem a little bit complicated. But it's the way that we reduce fractions, right? It's even the way that you reduce just normal fractions. Like if I had something like 4/6, and I know what you've learned how to do is to divide both top and bottom by 2. But we can really re-look at 4/6 as 2 divided by 2 times 2 divided by 3, right? Where 2 divided by 2 is 1, and 2 divided by 3 is what it is. It's 2 divided by 3. And 1 times 2 divided by 3 is 2 divided by 3, or 2/3. Okay. The real question becomes, well, how do you identify all of this? How do you know what gives you that fraction? And that's what we're going to work on in the coming problems. Okay. So, a lot that's important on this screen. Pause the video now. Think about it. All right. And then we're going to clear out the text. Okay. Here we go. Let's keep working on this. Exercise 3 says, rewrite each expression as the product of two fractions, one of which is equal to 1. Then write it as an equivalent but simpler expression. All right, let's take a look at letter A. This is kind of cool. I have 5 to the third down here and 5 to the 7th up here. That means that there's actually a 5 to the third hanging out in both of them, right? The question is, what else do we have? Well, in the numerator, what would we multiply 5 to the third by to get 5 to the 7th? Thinking about that exponent law, it would have to be 5 to the 4th, right? 5 to the third times 5 to the 4th would be 5 to the 7th. 5 to the third times 1 would be 5 to the third. But now all of this is equal to 1. And of course, we don't really need this thing down here. So we just get 5 to the 4th, right? Same deal up here. We have x to the 4th in the numerator, x to the 10th in the denominator. Now, if you think about GCF, because that's what we're really doing here, we're finding the greatest common factor of the numerator and denominator, and that's what's going in our numerator and denominator in this first fraction. What would we have here? We'd have an x to the 6th, right? X to the 4th times 1 is x to the 4th. X to the 4th times x to the 6th is x to the 10th. This now is equal to 1 times 1 divided by x to the 6th, and that gives us 1 divided by x to the 6th. Watch out, it would be tempting to say that's x to the 6th, but it's not, right? 1 divided by x to the 6th is very different than x to the 6th divided by 1. Ooh, letter C looks horrible. All right, let's take them a bit at a time. Here I have x to the 4th, here I have x to the 1st. So the best we're going to get in that fraction where they have the common, the GCF is an x to the 1st. Then I have y to the 8th and y to the 10th. The best that we're going to get there, which is quite a bit better, is y to the 8th, right? So really, these things are GCFs. They're the greatest common factor of the numerator and denominator. Now, what do I have left over? Well, if I look at the numerator, I took care of the y to the 8th, but I still have an x to the 3rd. And in the denominator, I took care of the x to the 1st, but I still have a y to the 2nd. This entire fraction is now equal to 1. That's x cubed divided by y squared. And so it simplifies into x cubed divided by y squared. All right, and that's it. Okay. The key, though, when you're separating these single fractions into two fractions, one of which is equal to 1, is to find that GCF, to find the largest thing, the largest sort of term that sits inside of both the numerator and denominator. Okay, and we'll get more work on that in even more complicated problems. So pause the video now and write down whatever you need to. All right, let's keep solving problems. Next page. Holy cow! Rewrite each of the following as equivalent exponential expressions in simplified exponential form. Ooh-wee! Wow, this is crazy. But let's do it. Let's jump right in. We'll do the easier one together, letter A, and then I'll have you really kind of pound on letter B by yourself, and then we'll go through it. Now, what do we do on this? Well, my piece of advice is always, when you don't know what to do anything you can do, just make sure it's not wrong. So, one thing that I certainly know is not wrong is if I rewrite that numerator as 3x squared times 3x squared times 3x squared. That's what it means to cube something. Now the denominator, well, that's just 9x to the fourth. Remember, it's not 9x times 9x times 9x times 9x times 9x because only the x is being raised to the fourth. Now I want to simplify this a little bit. 3 times 3 times 3 is 27. X squared times x squared times x squared is x to the sixth. And now we're really where we were in the last problem. Right? I want to look at the numerator. First look at the numbers, 27 and 9. Right? Their GCF is just 9. Then I look at x to the sixth and x to the fourth. Their GCF is x to the fourth. Right? Now the question is, what do I have left over? Well, I already took care of the 9, but I still need a 3 to get me up to 27. That's an x to the sixth. I need an x squared. Now here, I already have the 9x to the fourth, so I just need a 1. All of this fraction is equal to 1, and that's just equal to 3x squared. So that is my final answer, 3x squared. That's it. All right, letter B looks like a beast, and you do have to both manipulate the numerator and the denominator before you can even start simplifying. So pause the video now and take up to 5 minutes to work on letter B, okay? All right, let's go through it. So letter B. Okay, what we're going to do is we're going to first rewrite that out as 5x squared y cubed times 5x squared y cubed, right? That's just what it means to square something. And likewise, the denominator, 10xy times 10xy. All right, let's manipulate a little bit. Without formally writing down the associative and commutative properties, we're going to do 5 times 5 and get 25. X squared times x squared will give us x to the fourth. Y cubed times y cubed will give us y to the sixth. In the denominator, 10 times 10 will be 100. X times x will be x squared. And y times y will be y squared. In order to simplify this now, we're going to multiply two fractions together, one of which is 1. Look at the numbers. We've got 25 and 100. 25 goes into both of them. We have an x to the fourth and an x squared. The biggest thing that's common to both is x squared. Y to the sixth, y to the second. Again, biggest thing is y to the second. Now what do we have left? Well, in the numerator, we've taken care of the 25. And I'll need to have an x squared to bump that up to an x to the fourth. And I'll need a y to the fourth to get that up to a y to the sixth. That almost looks like y. In the denominator, I have a 25, but I'll need to multiply that by 4 to get 100, right? But I've already got the x squared and the y squared taken care of, if you will. I need to multiply by 1, but I don't really need to do that. So all of this fraction is equal to 1. All of that fraction is equal to x squared y to the fourth divided by 4. So that's my final answer, x squared y to the fourth divided by 4. Talk about some exponent work. This is good stuff, though. It's especially good to help you eventually prepare for taking Algebra 2. Okay? So, I'm going to clear out the screen. You pause the video and write down as much as you need to. Okay, here we go. All right, let's go through one more problem where we really try to understand the reasoning behind all of this. Now, in this problem, it shows a diagram on how to simplify one of these sort of more complicated fractions. And for each transition, it says give a reason, a rule, a property, etc., just a general description even, that justifies the manipulation. The point here isn't to get the technical language exactly correct. It's to explain, well, what's happening? What are we doing? Right? So, for instance, how do we explain going from this step to this step? And for me, that is simply the definition of an exponent. Right? That's just what an exponent means. All right. Now, what did we do when we went from this step to this step? We grouped those two 2's together and we grouped those x's together. We grouped that 4 and those two x's together and then those two 4's and that x together. But what does that mean when we group multiplication in a different order than what it was originally grouped? That does have a technical name. That's the associative property of multiplication. So being able to rearrange multiplication in any order we want is the associative property of multiplication. Then we just ungrouped this fraction. We put that here, and we put, whoops, well actually not just that, sorry, that was bad. Let me expand my circle a bit. All right, we put all of this here, and then we left the rest of it, if you will, this part of it here. Now, what would we say? How would we justify that? And I would justify that by simply saying multiplication of fractions. In other words, that just is the way fractions multiply. Then, of course, eventually that's equal to 1, and we get 1 divided by 16x. So it's important. A lot of times students kind of walk through mathematics just manipulating symbols, right? Not really having good reasoning on why things are working the way that they're working. Here, though, we see, all right, we use the properties of exponents to expand, if you will. Then we use the associative property of multiplication to rearrange in whatever order we feel the need to. And then we use the property of multiplying fractions to literally, if you will, unmultiply a fraction to get it to the product of two fractions, one of which is equal to 1. All right. So I'm going to clear this out. Write down what you need to. Okay, here we go. Let's finish up the lesson. Exponents are extremely important. They represent repeated multiplication, and that's something that we're going to see so much in Unit 6 that in fact we call the unit exponents, exponents, and more exponents. So obviously they're kind of important. Simplifying exponential expressions, fractions that involve exponents in the numerator and the denominator, is an important skill. Not so much for Common Core Algebra 1, although we will need it for the next few lessons, but it's a critical skill in Algebra 2. So it's good to have exposure for the first time at this level. For now, let me thank you for joining me for another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving.